Okay, yes. So I want to basically move on and talk about what I've called laser-based processing. My background is very much in using lasers for manufacturing, and it's certainly quite a big part of the center. It's certainly not the only technology, but so I'm going to introduce this part, and then there'll be another presentation on the other technologies that we'll have where we're purchasing equipment. So in laser-based manufacturing, first of all, just to give a little bit of background, Heriot-Watt, we have a long history of using industrial lasers for manufacturing processes. And that's both in the development of the lasers themselves and in using them in applications. And over the years, we've worked on applications such as aerospace, automotive, shipping, and more recently in particular, we've done quite a lot of stuff on medical implants, medical devices in a big area. We have quite a number of industrial end user collaborators. A few of them are listed down here. It's certainly not the full list. So you'll see examples of aerospace, defense, but also medical device areas such as Renishaw and Johnson & Johnson involved in those. We also have a lot of clinical collaborators. So at the bottom, I'm showing various clinicians. So David Jane is a colorectal surgeon. Kev Dhaliwal is a respiratory expert. Alan McNeil, urologist. Val Dillon, ophthalmologist. But there's a much longer list than that as well. So we have very good connections to the clinical side. We can really help us in terms of the problems that we're trying to solve. The key people in terms of the laser aspects of things here, so myself, and I've already mentioned Paulina Murawska, who's the technologist, one of the technology specialists. So she has a lot of experience of precision laser processes and associated engineering. Myself, yes, I've already said I've been working this for more than 20 years and a lot of grants in this area, research grants, and things like Innovate UK grants as well. John Shepherd, who's leading our laser surgery activity, so using lasers directly for surgery, but also the actual making the device that you need to get that laser into the body is equally important. So it's a medical device part of that. And Robert Thompson, who you'll also be hearing from later on our laser inscription activity to make really fine scale things which can be used for inside the body. So he'll tell you about that. But we have a lot of other researchers. So these are the people who do the work in the laboratory, research fellows, PhD students, who provide that manpower to do all the detailed research activity. So for those of you not familiar with using lasers for manufacturing, a little bit about why you want to use a laser, why it's a good thing to use. Essentially, it's a really controllable source of energy. You can take that energy, you can direct it remotely using an optical fiber. You can focus it down to a very small spot. You can move that spot around really, really quickly. You can pulse the laser beam so that it has really short pulses, or you could have a continuous beam. So it allows you to do all sorts of different things because you have that fantastic control of that energy. So you put that energy exactly where you want and exactly when you want. And as a result, lasers have been used in manufacturing, and they're being increasingly used in a wide range of manufacturing processes. So that's a little bit why we use lasers. Things we've used lasers for, so these are all examples of things we've used lasers for at Heriot-Watt in this case. You can join things with lasers, we can weld things together. You can, this is an example of glass being welded, or cut and then welded together to make microfluidics. We can remove material, so cutting or engraving, some engraving down the bottom there. You can add material, so 3D printing. This is 3D printing of metals using a laser. You can also modify materials. You can do things like polish the surface. So this part here is a cranial implant made using additive manufacturing, which uses a laser and then polished with another laser. This is a dental implant where we've also done some laser polishing. So we can do a huge wide range of things just by changing the properties of the laser beam and how we translate that laser beam over the surface. So very powerful technique. So what I want to do now is quickly describe the new equipment that we're purchasing for our facility. So firstly, a laser welding machine. This is actually a tender process at the moment, so it won't necessarily be that machine. It might be a different companies, but this is an example of one that we're looking at. Now, our philosophy in the center is to buy commercial pieces of kit. If you go in my research laboratories, you'll see that most of our setups are not commercial kit like this, but rather things we have put together ourselves. But we felt it's really important that companies have experience of using commercial kit, the kind of kit that they might purchase themselves, or if they're using a third party to do manufacturing, also the sort of machinery that would be used there in that case. And in this case, we can weld lots of different materials together, and these can be quite three-dimensional objects. So we can we define this to have a rotary stage, so we can weld circular things, for example, cylindrical objects. Another laser system, this is using a longer wavelength. The previous one was in the near infrared. This is further in the infrared. The wavelength is particularly good for doing machining of polymers. Nice little example there. Also for marking many materials. And one particular area we've applied such a system, a similar system for, is for making microfluidics for medical applications in the past. So that machine is actually purchased and in the university, waiting on the new lab. This is another laser which this is again this is going back to the near infrared, so a slightly shorter wavelength. That wavelength is particularly useful for processing metals. In this case, we're not welding, but we're doing things like engraving, marking. You can do color marking, sort of grayscale marking, as well as cutting and engraving, as mentioned. Another real state-of-the-art facility that's currently under tender process is a 3D microfabrication machine. So this links into Robert Thompson's area, where you can make amazing structures which are at a very fine scale, which we can then use as part of our medical devices. It's also, when you make things, you need to often analyze what you've made and make sure that it has the right properties, it's the right dimensions, has the material properties are correct, etc. So we're also setting up material characterization facilities, an SEM with various additional measurement techniques on it, optical microscopes, an ion beam polisher for sectioning materials out of parts at a very fine scale, and a 3D optical surface profilometer, which allows us to actually measure almost like complete objects made of multiple materials. This type of machine that we're going for will be able to provide, the beauty of it is because it uses more than one measurement technique, it can actually cope with lots of different material surfaces and do the measurement in one go, which most of these sort of optical surface instruments cannot do. So, but there's some couple of real state-of-the-art ones which are currently available. So this is currently, or I think, just about to go out for tender. Finally, additive manufacturing. 3D printing is clearly used a lot, certainly for prototyping, also low volume manufacturing, and in some cases even for fairly high volume manufacturing, depending on the application. So we're buying a couple of 3D printing machines. This one is a resin-based one, which provides very tough materials, high temperature materials, uses an ultraviolet laser to cure the resin, and also a filament-based one. This is slightly more common type of 3D printer instrument, but a particularly high performance one, which allows us to use many different types of filaments, etc., and also has a good high resolution. So often these 3D printers are used for the initial low volume manufacture, and then when you go to higher volumes, you might well change to an injection molding process, which you'll hear more about in a minute. Finally, yes, so this is not a laser, no lasers involved in this one, but we thought it's important to be able to demonstrate once you make things for medical use, you typically need to sterilize them. So being able to demonstrate a typical sterilization process, and also some of the packaging as well to keep things sterile. So that's me finished up. I know that was a fairly quick tour through stuff. Be very